All right, example 3. If you've kind of been on autopilot or something, this is a longer, more challenging problem. So make sure that you're focused and your distractions are away and you're paying attention. If you need to pause and replay it, feel free. All right, a regular nonagon. So just so you know, that's 9 sides, a 9-sided figure, is inscribed in a circle with a radius of 4 units. Find the area of the nonagon. So I know from my notes the area of a regular polygon is A equals 1/2 A times P. Oh, and just a side note, to kind of help keep it straight, big A is area, little a is apothem, so that we don't get confused. Okay, so let's think. So my overall goal is to find the area. To find the area, I need my little a, my apothem, and I need my perimeter. So right now I'm going to focus on finding my apothem, and then I'll find my perimeter. So a lot of people will think that 4 is the apothem. 4 is not the apothem. That is a radius because it's going from point L to J. So I am looking for LM and not LJ, So I am going to kind of draw this triangle a little bit perhaps bigger. With a little bit more room. So here's point L, here's point K, here's point M. Our goal is to find, I'm going to put an X, our goal is to find the apothem right there. So what do we know? We know that we have 2 congruent isosceles triangles. We know that these are right triangles. Excuse me, I misspoke. We know that we have an isosceles triangle with 4, 4, and the apothem, X, that is splitting that into 2 congruent triangles. So our goal is to find X. Let's maybe start with finding the central angle. So to find the central angle, every circle has 360 degrees. Divided by 9, a nonagon has 9 sides, I get 40 degrees. So my central angle, KLJ, is 40. That means each little part here is 20 degrees because the central angle, the big part, would be 40. So now if I kind of focus on either triangle, maybe I focus on just the top part, it's a right triangle and I'm trying to find X right here. So I can't use my Pythagorean theorem yet because I only know one side. It's not a 30, 60, 90. So I need to think back to my sine, cosine, tangent, my SOHCAHTOA. So I have 20 degrees right here for my angle. X right here, this is an adjacent side. This is an opposite side. And 4 is my hypotenuse. So my goal is to find adjacent. I know hypotenuse. Adjacent and hypotenuse. Think back to SOHCAHTOA. Which of these sine, cosine, tangent uses adjacent and hypotenuse, A and H? That should be cosine. So I'm going to say cosine of 20 degrees equals adjacent, adjacent is X, over hypotenuse, hypotenuse is 4. To solve this, for X, I have a fraction, which is division. To get rid of that, I multiply each side by 4. The 4's cancel. So I'm left with X. So in your calculator, you just would do 4 multiplied 4 times the cosine of 20 degrees. Make sure you're in degree mode. And I'm getting 3.8. And the rounding is not going to be super important on this. I will clearly be able to know, what you're doing and if you're a little bit off. So what we just found, X, that is actually my little a, my apothem. So I'm going to go ahead. I don't want to lose track of my overall goal, finding the area. I'm going to put in 3.8. Now all I need to do is find my perimeter, and then I can put in my area formula and find my answer. So now I need my perimeter. To find the perimeter of this nonagon, so here's kind of my perimeter, I need the length of one side, and then I can multiply by 9 because it is a regular polygon. They will all be the same length. So if I look back, now I need to find, I'll do green. I need to find the length of one side. So you actually, at this point, you have many choices for what you could do. You could do sine of 20. Sine of 20 equals maybe we'll call this y so we don't get confused, y over 4. You could do that. If you like the Pythagorean theorem, a squared plus b squared equals c squared, you could do that. So we're still focusing just on this yellow top triangle. If I use my Pythagorean theorem, x right here in red, this line, we found that was 3.8. So I could do 3.8 squared plus b squared equals c. My c would be 4 squared. So kind of pick a method. You could do this method up here. You could do this method here. When you do that, I am getting 1.25 for my answer. So 1.25. Now remember, since we were just looking at this yellow shaded triangle, that would just be from here to here. So the whole length of the side, we would need to double that. 1.25 and 1.25 would be 2.5. So each side in this regular nonagon, each side is 2.5 units. Each side is 2.5 units. My formula is asking for perimeter, so I need to do 2.5 times 9, and I am getting for that 22.5. Then my last step, I know it's a lot of work here. My last step, since the goal is to find the area, is I'm just going to type all of this in to my calculator, 1/2 times 3.8 times 22.5, and I am getting 42.75 units squared. Now I will definitely be able to see, if you're pretty close, but you have something slightly different because you use sine of 20 to find y instead of the Pythagorean theorem, or you round it a little bit, so I will be able to tell that versus if you just did something super wrong. Okay, again, if you need to rewatch this, feel free. Just kind of as a summary of what we did is we tried to find the area using this formula. First we found the apothem. We found the central angle. We did 360 divided by 90. We got 40. We set up a right triangle in yellow here. We knew that this angle is 20 degrees because half of the central angle, 40 divided by 2 is 20. This 4 of the hypotenuse was given to you in the problem. We found the apothem first, this x first, by doing cosine of, this is all this work over here. We did this, cosine of 20 equals x divided by 4. We solved that for x. We got 3.8. We put that in right here for our apothem formula. For finding perimeter, we found one side length. I used the Pythagorean theorem. You could also have used sine of 20 equals y over x. Then lastly, we put that all into our area formula, and we found our final overall answer, which was 42.75. All right, last example. You're decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon, so 8 sides, with a 15-inch radius of about, with 15 sides, 15-inch sides, and a radius of 19.6 inches. What is the area you're covering? So again, my goal is finding the area. It's a regular polygon, so I'm using that area equals 1/2 times apothem times perimeter. And so there are many ways that you could do this. In this problem, the perimeter is going to be kind of a little bit easier to find right away because I know the side length, one side length is 15 inches. I know there are 8 sides because it is an octagon. So 8 times 15. My perimeter is 120 inches. So I can go ahead and put that into my formula. And now I need to still find the apothem. So the perimeter was a little bit easier on this one. For the apothem, you're going to have several choices. You can use trig, but on this one, I think you also can kind of get away with just using the Pythagorean theorem if that's your preference. Okay. So I'm going to zoom this in a little bit, and maybe we'll draw in red. So we're going to kind of start the same situation that we had in the other problem in example 3. We have this triangle. My goal is to find the apothem, right there, the apothem. So I need to find the angles. Let's start by finding the central angle. Well, actually, if you look at this picture here, my goal is to find x, and I know that PQ is 15. And since these are congruent triangles, this is 7.5 and 7.5. So if I want to find x, I can just use my Pythagorean theorem, my a squared plus b squared equals c squared. And my c is 19.6, and my a or b is 7.5. So I can kind of plug everything in like this. If I want to avoid using the trig, I do that. I square those, I subtract, I take the square root. I get 18.1 for my apothem. So now I'm ready to use my area formula, 1/2 times 18.1 times 120, and I get 1,086 square inches. 1,086 square inches. You could use trig and a central angle like we did in example 3, but since this one gives you the length of the side, you also don't need to if you don't want to. Okay, so homework 11.3 will be on big ideas. The summary: what is the formula for the area of a kite and a rhombus? They have the same formula. What is the area formula for a regular polygon? What is an apothem? And I really want to make sure that people understand the difference between a radius and an apothem. So they're both line segments that go from the center to the outside of a inscribed polygon, but how can you tell which line segment is the radius versus the apothem? Thank you.